welcome to another session with Learning Together in Math. It has been very exciting for us, both in English and in math, to have this privilege to share with you some concepts that could be very helpful depending on what your needs are. Today, I would like to address something that is used very often, but at the same time, something that is used to manipulate and to misrepresent. The simple word that is often used is the word average. Average. What is average? That's a term often used, but it can be used to convey information in a very convenient and subtle way. Today, I would like to share with you that the word average has different forms of measurement. And as a result of that, it's important for you to know what form is being used when you're being told that this is the average. The truth is, the different forms are not illegal. However, if one form is used, it can misrepresent or give you the false impression. And I'm hoping to clarify that as we go through this session together. So I'm going to subtitle the presentation, Measures of Central Tendency. And the bottom line is, numbers do not lie. However, people do lie with numbers. That's really the issue. The numbers themselves do not lie, but people have a way of using numbers in such a manner that it could be deceptive, misleading, and also incorrect in terms of the information that is being conveyed. So after this presentation, you will be a little bit more educated, a little bit more understanding of what really it means to represent a quantity in a meaningful manner using the word average. Okay? So I'm going to highlight some keywords that we plan to address, and hopefully we'll check them off one by one. So, for those who do not know, my school is closed, so I have to present using a different method today than I've used in the last couple sessions. So please bear with me. It's a little different, however, we'll get through this together. So, here's what we're going to cover today. Measures of central measures of central tendency. And what we're really talking about is averages. I deliberately put the word averages in quotes because, again, many times we talk about averages, we say add the numbers and divide by the number of numbers. That's what most people think when they think of average. But truthfully, average comes in different forms, and that's just one form of an average. But there are other forms. What are the forms that we're going to be talking about? We're going to be talking about the mean, the mode, the median, and the range. Those are the three things we're going to address: the mean, the mode, and the median. Mean, mode, and median. So by the time, and of course the range is there, by the time we're finished, you should be able to become experts at these four terms. So Let's deal with the mean. The mean is the one that you have always known as the average. This is where you add all the terms and divide by the number of terms. For example, if I gave you the numbers 2, 6, 8, 5, 4, 1, 2, 3, 4, 5, 6, 7, 8. Yes, if I gave you these 10 numbers and I asked you what is the mean, you get that number by adding all 10 numbers up and divide it by 10. So the mean equal to 3 plus 2 plus 6 plus 8 plus 5 plus 4 plus 6 plus 7 plus 9 plus 6, all divided by 10. So let's make sure we have all the numbers. 3 plus 2 plus 6 plus 8 plus 5 plus 4 plus 6 plus 7 plus 9 plus 6. Beautiful. And if we were to add these, that's 5, 11, 19, 24, 28, 34, 41, 50, 56. So it's 56 divided by 10. 56 divided by 10, and that's approximately 5.6. We're saying that the mean of these 10 numbers is 5.6, okay? Or the average of those 10 numbers is 5.6. I could also show you a little trick as to how you could do this addition without going through all of this work. There is a way that you could go through this exercise without doing all that I've just done. There's a quicker way to do it. And I'm going to share that with you. So let me just make some space on the board. Okay, so look at these numbers, 3, 2, 6, 8, 5, 4, 6, 7, 9, and 6. Suppose you estimated that the mean was, suppose you made an estimate that the mean was 5. You could make a list of the differences and then at the end come up with your answer. So if your estimate is equal to 5, so some of the numbers are above 5 and some of the numbers are below 5. So let's go through. 3 is 2 below. 2 is 3 below. 6 is 1 above. 8 is 3 above. 5 is 0, so you don't have to do anything. 4 is 1 below. 6 is 1 above. 7, 2 above. 9, 4 above. And 6, 1 above. So you know that negatives cancel positives. So what do we end up with? Well, 2 cancels 2, 3 cancels 3, and 1 cancels 1. So we're left with what? 1 plus 4 plus 1. We're left with 6. So the answer is going to be 5 plus, it's positive 6. And the average of that is 6 over 10. 6 over 10 is 0.6. So we end up with 5.6. Same answer. Many of you might never have seen that before, but that's a quick way that you could do an average without doing all the big numbers, without adding all the big numbers, if you didn't have a calculator. So let's do another one. Let's do another one. We're going to do the mean again, or the average again. Okay, so random numbers, say 10, 12, 9, 6, 7, 3, 6, 8, 13, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 numbers. So, if we were to add all the numbers up, what do we get? Okay, so let's go. 2, 9, 11, 17, 24, 32, 35, 40, 48, 49. 4, 5, 6, 7, 8. Let me double check because I did a rough calculation. 1, 9, 14, 17, 25, 32, 38, 47, 48, 49. 4, 5, 6, 7, 8. 89 divided by 10, 8.9. Suppose we said that, look at it and we say, oh, the mean is about 10. So let's use an estimate of 10. Let's check the positives and the negatives. This is 0. This is 2. This is 1 below. This is 4 below. This is 3 below. This is 2 below. This is 3 above. This is 5 below. That is 2 below. And that's 1 above. So that's our differences. So 2 cancels 2. 3 cancels 3. 1 cancels 1. What are we left with? We have 4 plus 5 is 9 plus 2, 11. So now it's going to be equal to 10. So the mean is going to be equal to 10. And since it's negative, we have an overall negative 11. So it's 10 minus 11 over 10 because there are 10 numbers. So it's the average difference. The total difference is negative 11. The average of the differences is negative 11 over 10. So it's equal to 10 minus 1.1 equal to 8.9. So that's a little trick as to how you could find the average by using an estimate and then using the differences. Okay, so that's one thing down. Let's try something else. Okay, I love to give tests. So suppose I told you that Mark's average mean score of 4 tests is 90. If 3 of the scores are 87, 96, and 89, what is the missing score? Mark did 4 tests and his average was a 90. You are given 3 of the test scores, 87, 96, and 89, and you're asked, what is the missing score? How much did he make on that 4th test so that his average is 90? You say, okay, so that his mean is 90. Here, the average and the mean are the same thing. That's one way we're using the mean. You say, okay, how do we find the mean? We find the mean by adding up all the scores and dividing by 4, because there were 4 tests. We do not know the 4th. We do not know one that's missing. So let's call it X. Give it a number, X. Give it a letter. So now we have 87 plus 96 plus 89 plus the missing score divided by 4 must be equal to 90. The 4 scores divided by 4, you add up the 4 scores, divide by 4, you need to get 90. And then, of course, you can get rid of this 4 by multiplying both sides by 4. We'll add these 2 numbers together, these 3 numbers. So 7 and 6, 13 and 9, 22. 2 and 8, 10, 19, 27. 272, oops. 272 plus X all over 4 is equal to 90. So now multiply both sides by 4, we end up with 272 plus X equal to 4 times 90, 360. So therefore, X has to be 360 take away 272. And that happens to be, if I'm not mistaken, 88. So the missing score, X equal to 88. That's one way you could solve a question involving the mean, okay? So that's one item. We'll come back to some more examples later on. Another item we talked about is the mode. What is the mode? Given a set of numbers or given a set of data, the mode is the one that occurs the most. That's what mode is, the one that occurs the most. So if I gave you, say for example, 4, 3, 2, 3, 7, 4, 5, 8, and I asked you what is the mode, you could look at these and say, let's do another one. Or rather, change this number. If I gave you these numbers and I asked you what is the mode, it's asking which item or which number occurred the most. So in this case, the mode is 1, 2, 3. That has the highest occurrence, so the mode equal to 3. At the end, I will share with you when it's best to use a particular measure of central tendency, whether the mean, the mode, or the median, or even when the range can be very, very useful. Okay? So that's the mode. So, what happens if you were given something like this? What happens if you were given an example like this and you ask, what is the mode? We look at it, we notice that 12 occurred 1, 2, 3 times. We notice that 10 occurred 1, 2, 3 times. These are the modes. So this particular example has 2 modes. There are 2 things that tie for the highest. So in one set of data, you can have more than one mode. Okay, so that's covered. It all has to do with the one that occurs the most. In this case, there are 2 with that record. So there was a tie. Okay, so now we have dealt with the mean, we have dealt with the mode, and we need to go now to the median. And then afterward, we'll put it all together and see what happens. Median. When you think of the median, if you're a driver, you think of the median, say stay off the median. It's that middle, the center of your driving lane, the median. Okay? Well, the median in math, in statistics, is referring to the item that occurs in the middle once you put it in numerical order. So this is must be in numerical. Okay, so the first thing you have to do if you're given a list, you have to order it from least to greatest, and then look for the one that is smack in the middle. Say, for example, yes. So we're given these 1, 2, 3, 4, 5, 6, 7 numbers, and you need to find the median. Okay, so first thing first, so we have to place them in order. So we will have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 8. And the number that's smack in the middle is the number 4. That's smack in the middle. So the median equal to 4. The number that's right in the middle. So far, so good? Great. Let's do another example. Again, what did we do first? We ordered it from least to greatest, and we look for the one in the middle. So think about it. Mode is the most frequently occurring, most frequently occurring. Median, the one in the middle. Okay? What about this? Okay, what is the median for this set of numbers? Ah, Let's see. Let's order. This in order, we end up with 6, 7, 8, 8, 9, 10, 11, 12. So now we have it in order. 6, 7, 8, 8, 9, 10, 11, 12. So that's the order. So now we look for the one in the middle. Well, 1, 2, 3, 4, 5, 6, 7, 8. The middle is made up of 2 numbers. 2 numbers will be found in the middle. There are 3 to the left, 3 to the right. 2 numbers in the middle. So what is the median? Wow. The median is going to be equal to the arithmetic mean, or the mean of those 2 middle numbers. So it's going to be 8 plus 9 over 2, which is equal to 8.5, or 8.5. So what do you notice? That the median could be a number that don't even exist in the list. Wow. And again, keep in mind, before we're finished, we're going to discuss when is it critical to use what kind of measure of central tendency, which one of them to use to give an idea of what the population that we're studying really looks like. Which one will give the most meaningful value to represent the population that you're studying, okay, or the data that you're studying. So we have the median, we have the mode, and now let's talk about the range. The range. I just want to say right here that it's interesting that in the English language, we often find that one word can be used to mean different things depending on what context it's used in. For example, the word range. When we start talking about graphs, we're going to be talking about the domain and the range. The domain and the range. But here, for the range, or when we're talking about functions, we talk about the input and the output, where the output represents the range. But here, the range is the difference between the largest and the smallest So the range is just the difference between the largest and the smallest. That's the range. So, example, if I gave you 2, 7, 6, 5, 10, 14, 3, 1, 9, and I asked for the range is equal to, look for the highest number, which in this case is 14, and look for the lowest number, in this case it's 1. So the range is 13. So let's go over the definitions again. For the mean, we add all the terms and divide by the number of terms. For the mode, we look for the term that occurs the most. For the median, we take all the numbers, put them in numerical order from the least to the greatest, and look for the number smack in the middle. If it's an odd number of terms, there will be one term in the middle. But if there's an even number of terms, we'll have to take the two middle terms, add them together, and divide by 2. For the range, look for the highest value, look for the lowest value, subtract them, that's the range. The difference between the highest and the lowest is the range, okay? Just before we go into the interpretation as to when to use what, I just want to quickly just mention something to you. You might see an example like this. Find the mean mode median, and range of following. Yes, this is what is called a frequency table. Frequency table. What does it mean? It's telling you that in the set of data that we're studying, 2 occurred 6 times, 3 occurred 4 times, 5 occurred twice, and 7 occurred 5 times. So if you're asked to find the mean, then we have to find the total of all these numbers and divide by the number of numbers. If we're asked to find the mode, that to me is one of the easiest ones of all this. Which one of these data items occurred the most? So from this we can see that 2 occurred 6 times. So right away we can say that the mode equal to 2. Because 2 is a number that has a frequency of 6. So you didn't have to do any calculation, just look at the table, interpret the information, there it is. 1 down, 3 to go. What is the range? The range is the difference between the largest and the smallest. The largest value is 7, the smallest is 2. So the difference is, the range is going to be 7 take away 2 gives us 5. Now the median is a little tricky. First thing first, the numbers are already in numerical order. You have 6 2s, 4 3s, 2 5s, and 5 7s, listed going in increasing order. How many numbers altogether do we have? 10, 17. What is the middle term if you have 17 terms? Which term is the middle? So from 1 to 17, I think the 9th term would be our median. The 9th term, because it's total of 17, this is 17. So the middle term is 9, because that means you have 8 to the left, 8 to the right. So term number 9 is your median. So check this out. The first 6 terms is 2. The ninth term is going to be one of the threes. So the median is equal to 3. And then finally, now we need to find the range, not the range, sorry, the mean. The mean involves some calculation. And so I'm going to erase this so that we can do the calculation. So there are 6 2's. That gives us a total of 6 times 2 is 12. There are 4 3's. 4 times 3 is 12. There are 2 5's. 2 times 5 is 10. And 5 times 7 is 35. When we add all of those together, what do we end up with? That's 9, and this is 6. So that gives us 69. So the average of these numbers has to be 69 divided by the number of terms, which is 17. So the mean is equal to 69 divided by 17. And of course, we see that that's going to be what? 4 point something. We do 69. Okay, and 7 7s 49, so 6 7s 42, 6 1 6, approximately 6, 4.06, approximately 4.06. So this is how we'll be able to calculate the mean from the frequency table. Okay? Great. Good. Okay, so you're asked now to find two, 4, 1, 3, 1, 2, 5, 1, 2, 1, 3, 1, 2, 5, 4. Sometimes if you're given a lot of numbers, you might need to create your frequency table. So this is your number, this is your tally, and this is your frequency. So what are the numbers we have? The numbers we have are 1, 2, 3, 4, 5. 1, that's it. 1 to 5. So 2 occurs once, cross it off. And the tally is a check for each time it occurs. 4 occurs once, so we check it off. 1 occurs once, 3 occurs once, 1 occurs a second time, 2 occurs a second time, 5 occurs once, 1 occurs a second time, 2 occurs another time, 1 occurs another time, 3 occurs a second time, 1 occurs a fifth time, 2 occurs, 5 occurs, and 4 occurs. So now the frequency for 1, we see that it's 5. Each tally is 1. For 2, it's 4. For 3, it's 2. For 4, it's 2. And for 5, it's 2. This gives me a total of 9 and 4 and 6, 15. And I can double check to make sure that it's correct. Cross reference 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I know that I've accounted for all 15 numbers. And now I can now answer the questions. The mode, 5 is the highest frequency, so the mode is 1. The median, so let's write them down. Mode 1. The median, if there are 15 terms, then term number 8 is the middle term. So the median equal to the 8th term. And in this case, this is 5 and 4, 9. So term 8 and 9 will be right here. So it is going to be 2. Then we talk about the range. The range is equal to 5 take away 1 gives me 4. And now to get the actual mean, we need to do the product right here. 5 times 1 is 5. 4 times 2 is 8. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. So this is getting our mean using the frequency table. So 10 plus 8, 18, 24, 32, 37. So the answer is going to be 37 divided by 15. And already we can see that it's approximately 2.5 as our mean. Let me do 37 divided by 15. It's approximately 2.5. Okay, so the average, the mean for all these numbers is about 2.5. So let's talk about how the numbers can be misused, how the different terms can be misused. Okay, suppose you're going on a trip and they say to you that you're going on a trip to the beach, and they say that the average age equal to 15. The average age is 15 years. So you automatically start thinking that, wait a minute, so the people are going, they are young people going. But look what happened. Suppose the people going on this trip were, say, 10, 9, 8, 7, 10, and then there's somebody who is, say, there's a bigger number. 75. This one number alone will bring the mean up to let you get the impression that the people are older than they are. Look at it. The majority of the people going are little kids. However, this person's age, when added into these, creates an image that the average age is older than they really are. This person doesn't belong to the group, and that number is called an outlier. When an item or a couple items do not belong to a group, they can easily give the wrong impression about what the group looks like. We call them outliers. Use an example. Let's talk about houses, the cost of houses. If the houses on the block cost 120K, 130K, 140K, 125K, and then Usain Bolt built a house for 2.5 million. Now, the four houses here, all of a sudden, if you were to do the average of these houses, the cost of these houses, the mean value would make these houses appear as if they are worth 400,000. So you would start thinking that these houses are pretty nice value houses, only to find that only one house alone forces the numbers to go up and give the wrong impression. So the question you would ask is, what number might be a better representation of the group? Well, I think if we use the median, it's going to give a better example. As a matter of fact, oftentimes the outliers are best taken out of the data and not used when representing the data because they do not give a true picture of the representation or the population that you're studying. Okay? Now, if we're dealing with, say, age, if you're going to a party and you're trying to get an idea of who are the people at the party, then having the most frequently occurring age might be a good representation to let you know where you stand relative to the people who are attending the party. So the mode might be a better representation. If you're buying a house in a neighborhood, where say, for example, 10,000 houses, the median tells you that half of the houses cost more and half cost less. Okay? If you're talking about, say, for example, salaries, if you're looking at a career and you want to have an understanding as to what type of lifestyle you can afford if you choose a certain career, you might want to look at the range of income. That might be very helpful. If you know that people starting out in that field, say, earn, that's a number, say 50,000 to 70,000. It gives you an idea. So if somebody makes you an offer, you can get an idea if you're really close to the bottom or if you're closer to the top. So the range might be a more useful idea. Okay? Of course, remember that outliers throw off the mean. Outliers can create a big problem where the mean is concerned. The median can be more useful than the mean oftentimes. Okay? Now, when dealing with grades for a class, the mean could be a better representation of your ability. For example, if you score 90, 80, 70, and then one score is 10, this really doesn't represent your ability. This is an outlier. It will drag your average down. But if the numbers are close, for example, if the other score was, say, 78, then the mean would work, would give a good idea as to what your aptitude is. So let's reason out. So the mean becomes useful when the numbers are fairly close together. In other words, the range is not huge. When the range is wide, then it might be better to use the mode or the median. The median might be a better example because it gives you an idea where you fall within the scope of things. So this is stuff to keep in mind, that oftentimes you're given the impression that really is not the true picture of what the case might be. So you need to be mindful and you need to understand what measure of central tendency is being used and whether it is appropriate or it's not. Are there outliers that are present that are distorting the figures? Finally, I would like to just mention something that is very important to people applying to go to colleges. Is the SAT scores. And that has to do with the Scholastic Aptitude Test. This is used by many colleges in the United States to try and measure how qualified you are to perform well at their institutions. So depending on what school you're going to, they might use the SAT score to give you a gauge as to whether you qualify for that school. So suppose you're applying to a school, you are say in Jamaica, or you're in Trinidad, you're in Guyana, wherever you are, and you're applying to a certain college in the United States, and you saw that the range of values for their SAT score, which the max is 1600. That's the max, and the minimum is 400. So you can score between 400 up to a maximum of 1600. So if college X, if you look at the students who are freshmen going in, if their scores are say between 1050 to 1200, that gives you an idea of the performance of those kids compared to another school, college M, that has something like 1250 to 1400. This gives you an idea of the academic rigor that this college pushes compared to say this one. For this one, you don't need to have a high score to get in. For this one, you need to have more muscle, academic muscle, in order to get this. So these numbers can be very helpful to understand what is it that you're working with. I do hope that the presentation that we have today, though possibly simplistic, gives you an idea how numbers can be used to manipulate the thought process to convince you of situations that really aren't true in terms of the true reality. For example, we talked about what outliers do when we use the mean, and a large outlier could drag your mean up, or a reduced value that is extra small relative to the population could pull your mean down and give the wrong impression. Okay, this is the end of our session today. I encourage you to stay tuned. Our next session is going to be on function and function notation. That's going to be very exciting. I look forward to sharing with you next time around. Enjoy the rest of the evening. And on behalf of Ruseas and the Ruseas Student Association, we thank you for sharing this time with us, and we hope that you benefited from this experience. If you do, we encourage you to like and subscribe to our YouTube channel. All the best.